Hi everyone, I continue on the lesson. I would like to do topic 15, 16, 17, which are more about algebra earlier in the semester that you have energy because they are very good lessons for math 273. So I start with factoring algebraic expressions and I want to show you how to factor. Factoring can be very hard, can be very easy and fun. So it depends on the question. So I show you the way. There are many other way of factoring, but you don't see them all. But these things that you see, still they can be challenging. So I want you to do many practice. So I added examples to the lesson. I added practice to Blackboard, and also you can search and find on your own and do many practices. Okay, so here we start with factoring and factors. What are factors? What is the meaning of factors? And I'm not really fan of definitions and telling steps, and I want to show you an examples, but I just tell you this. Numbers and variables that if you multiply them, you reach to the original number or original algebraic expression, so are factors. So when I just break something to numbers or algebraic expression that if I multiply them back, I reach to the same original thing. So again, I want to show you an example, and I really don't ask for definitions so in future. So I just want you to know it. Okay, factoring is the process of doing factors. So factoring, okay? So here, for example, if I want to talk about a number, so when I say factor that number means you break the number to numbers that if you multiply them, you reach to the same result. For example, for 3, because 3 is a prime number, so I just have 1 and 3 here. How about 6? I have 1 and 6. Also, I have 2 and 3, so 2, 3, and 6. So they are all factors. How about 6x? I have 1, 2, 3, and 6 and x. Okay? How about x, y, z? So x, y, z, because yes, that's when I factor, so that's that. How about this? So I can say 1, I can say 2, I can say 3, I can say 6, I can say x, I can say y, I can say z. So when I multiply them, so it doesn't mean I multiply all of them. No. So if I multiply all of them, it will be 2 multiple 3, which is 6, and 6 multiple 6 is 36. I don't mean you multiply all of them. For example, you multiply this and this and this and this and this, or you multiply this or this or this or this or this or this, so you reach to the same result. Okay, so when you break the number that you or math or expression that you cannot break more, so we call that factoring. So factoring can be it can be any factor. So if I say 4D, for example, I say 4 multiple 10, that's factor. Okay, but I don't accept it because I want to see prime factoring, means you cannot continue to factor. Okay, so for example, 10 is 2 multiple 5. How about 9 is 3 squared? I cannot continue more. How about 20? Yes, 2 multiple 10, I know. But I can continue to factor. So I can say it's 2 multiple 10, but I don't accept because I can continue. So I do 2 squared multiple 5. Yes, perfect. See, I am continuing to factor to prime numbers. These are all prime numbers. 2 is prime number, 5 is prime number, 3 is prime number. Okay, so how about 4D? Yes, 4 multiple 10. Come on, yes, that's factor. Yes, I know, but it's not prime numbers. Okay, so it's 2 to power 3 multiple 5 because it's both prime numbers. Okay, so when I say factor, so we really like to see prime factors. Okay, means when you try to continue, you can't to break it more. Okay, so factoring polynomials, so you have to factor to something, for example, to brackets, or maybe a term multiple another bracket, then that when you multiply them back, you reach to the same result. Okay, so when we factor a polynomial, we express it as a product multiplication of two or more polynomials. Okay, it's reverse process of expanding. So if you multiply them back, then you expand it. So it's exactly like Pascal triangle. You try to expand and make it large. Okay, so now we go back. So we want to just make it small and factor. Okay, so here we can use it, we can use this in order to solve for a variable. So factoring helps us to solve for a variable. Okay, so right now I would like to, like, for example, do this. So for example, if I give you this, if I give you x squared, for example, for example 5x, oops, what happened? So x squared 5x plus 6, okay, equals 0. Okay, then I tell you find x. Solve this equation to find x. The meaning is you are finding x-intercepts, because you are finding where this y equal x squared plus 5x plus 6 touches x-axis. Means what is x when y is 0, and we know that's definition of x-intercept. Okay, so when I tell you find zeros or find roots, for example, for y means y equals 0, find x, you are finding x-intercept. And that can be very useful if you know how to factor. You factor, and then you can say equals 0, and then you can find x, and for example, just x, just find what is x. Of course, y is 0 when you find x, because that's a root, or you are really searching for x-intercept. Okay, so you can find the answer for that. So there are many ways to factor, so many ways. We show you some of them. The first one is common factoring. Common factoring, when you factor something in common. Okay, something must be in common, remember, not just in the first term. No, it has to be in all terms. Okay, for example, like here, I have A in both of them. So I can factor A. If I multiply back, then I see the same result. Okay, so now let's do it here. Okay, so I see A, I see A, I see A. So I can factor that. A multiple A plus B. Done. Equal. I see 4, I see k, so I factor 4k, so k plus 4 is just going to stay. Okay, remember, if I multiply back, that can be my check. I have to see the same result. Okay, equal. What do I factor? Can I factor x? No, x is not in common. 3 is in common. Okay, so 3 multiple 3x plus 1. Okay, how about this one? Okay, this one I cannot really factor anything, but I notice when even I see, okay, nothing is in common, one of them 4, one of them minus b, for sure I can factor minus 1. When you see you cannot factor anything, maybe minus 1 helps you just to see that you can factor. Maybe for example, maybe it helps you to go to the next step. Okay, so I can factor minus 1. I don't see anything in common, but minus 1 can be in common. So it is b minus 4. Remember, when I multiply back, I have to see the same result. So maybe I use equal sign. Did I use? Yes, yes. Okay, so how about here? What do I see in common? Okay, I see 5m squared in common. Okay, so 5m minus 3. Am I right? Yes. Okay, what do I see in common? Do I see anything in common? X is in first and second, y is in second and third. No, I have nothing in common, because it must be common in all of them. Okay, so it doesn't work. I cannot factor. Okay, so no, not to factor. Okay, oops. Unless I tell you x is, for example, 2 and y is 8, and then you see, oh yes, I can, for example, just include that I have a number and then I can factor that number. That's different. But when I see x squared and xy and y, no, of course no, because I don't see anything in common. What do you see in common here? Here I see 9. Okay, so equal 9a cubed plus 3x squared. Here I see x. Oh, I see 3x. Okay, so 3x multiple x power 4 minus 6x squared plus 3. Am I right? 2, sorry, here 2, because when I multiple must be, yes, must be the same result, and it is now. Okay, so perfect. Now can I factor here? Okay, yes, I can factor 4y, so 3 stays, minus 2y plus 6y squared, right? Yes. How about here? So what do I see here? Okay, so here I see 3, yes, I see w cubed. So what is left? So here 8w squared plus 1. Remember, when nothing is left, it's 1. Because you factor, many times I see a student, they write 0, wrong. Because when I multiply, I have to go back to the same result. How about here? How about here? Okay, so here I have 12, yes. I have x, yes, but I don't have y because the last one doesn't have y. So 12x multiple 2y squared minus y plus 3x. Yes. How about next? Okay, so 9, yes. A squared, yes. B squared, yes. Okay, so I can factor 9 is common, a squared is common, and b squared is common, right? Okay, so 9a squared b squared multiple 3 is left plus b is left minus 2a is left. Yes, yes. Okay, so how about here? Here, do you see anything? Okay, yes, 6 is common, n squared, yes, but m is common. Okay, so 6 n squared m, which is n squared is gone, 6 is gone, m squared plus 3 mn minus 2. Okay, so now I can go back, so I can just so go to the next step, which, oh my goodness, what's wrong here? Okay, so yeah, I can go to difference of two squares. Oops, I'm not sure why it's so crazy. Okay, can I? No. Okay, so hopefully you can see this. So here, yes, so let me just have this. Okay, so difference of a square. Okay, look at this one here. When you multiple, what happened? When you multiple, see, you have a, you have b, you have minus plus, see, you have two things the same, a b, one of them minus, one of them plus in between. When you multiple, you can see, if you do FOIL, you multiple, so a with a with b, minus b with a, then you can see ab and ba cancel each other. So you have this. So if you see a just two squares in subtraction, two square is indifference, so you have two squares that are separated by a minus. So when you have two squares that are subtracted or separated by a minus, then you can factor, and we call this difference of a square. difference of a square. So that's what we say. Okay, so here I have some formula for you. If I have a squared minus b squared is this one. But if I have plus between them, I cannot factor. Okay? So keep this in your mind because it's plus between them and both of them are a square. You cannot factor. How about if you have power 4? Can I factor? Yes, I can do a squared minus b squared plus a squared plus b squared. The same for power 2 that you have. 2, 2, now you have 4, 4. So you do. But then you can continue. You can continue for this one. You can continue to these two. But for the other one, you cannot. How about if you have power 4 plus? Power 4 plus, power 4 plus between, you cannot factor because it's plus between them. I want to have your attention here. If I have power 3 cube plus and minus, if I have cube plus and minus, I can factor this way. Okay, so this one, I remember when I was in my country, we used to say small and large. Okay, so we used to say factor small and large, and then we knew that it's the factorization of cubed minus cubed plus. You don't see many questions of these, but I wanted you to know it because in future, if you continue your studies, you are going to have math in future, so you will see these, and I don't want you to think that power 3 is the same as power 2. For example, if I have minus between, I can factor. If I have plus, I cannot factor. Odd numbers are different. If you have odd numbers, they are different. Okay, so I really want you to know the factorization of odd as well. Okay, so these are just lessons. Okay, so look at these, so important. Okay, so now let's do the examples. So here, y squared minus 2 squared, right? Which is y minus 2 multiple y plus 2. Look at the formula. How about the next? 2x squared minus 5 squared, which is 2x minus 5 multiple 2x plus 5. How about this? 4x squared minus 3 squared, which is 4x minus 3 multiple 4x plus 3. Am I right there? So yeah, plus and minus, yeah. Okay, how about this? Oh, it's it's minus 81 y cubed, sorry, y power 4. Okay, so can I say it is y power 4 minus 81? Oh yes, this is very just, I like to see this way. Okay, so here I notice, oh yes, I can say it's y squared minus 9 multiple y squared plus 9. Can I continue? Yes, as I said, I can do y minus 3 multiple y plus 3, but how about the next? I cannot factor plus, I cannot. I have the formula there. I can't. Okay, so now I can practice here. Do practice question. Okay, so y minus 4 multiple y plus 4. Oops. Yeah, I use equal. So here equal. Oh, what do you see here? Oh, I see 5a minus 6 multiple 5a plus 6. What do we see here? Remember, when you see 1, you can say 1 to any power you need. Okay? Any power you need. Oh, here, do I need 1 power 2? No, I need 1 power 4 because I see the other 1 power 4. Okay, so I can say 1 power 4 minus 2t power 4. Yes? Yeah. So I can say 1 minus 2t power 2 multiple 1 plus 2t power 2. Oops. Now I continue. It is 1 minus 2t multiple 1 plus 2t 1 plus 4t squared. Because for the other one I cannot factor. Okay? Yeah. Oh, nice. Okay, so how about here? Equal. So did I use equal all of them? Yes, 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 yes. Yeah, okay, so yeah, equal here. And equal here. Otherwise won't be correct. So just mathematically, you know. Okay, so here it is 5x minus 8y multiple 5x plus 8y. Okay. Oh, how about next? So maybe for some numbers you have to use your calculator. Here I use my calculator and I see it is 10p squared minus 11q squared. For some numbers I know. For example, for 1 I know it's 1 squared. For 4 I know it's 2 squared. For 9 I know it's 3 squared. 16 4 squared. 25 5 squared. 36 6 squared. 49 7 squared. 64 8 squared. 81 9 squared and 110 squared. So 121, so 144. So but for the rest I don't remember, so I use my calculator. Okay, so I use my calculator with radical. So if I see radical 121 is a number, whole number, then yes, why not, I can continue to use it. Okay, so it is 10p minus 11q multiple 10p plus 11q. Okay, how about here? Oh, here. One of them 2, one of them 32. I can't do anything. So because I cannot write them as just a squared. I cannot write 2 something squared. I cannot write 32 a whole number squared. Remember, maybe you have to think about common factoring first. So remember, when I give you question in quiz and test, the first thing you have to check is common factoring. Yes, maybe you can do common factoring. Do I have anything in common? Yes, 2. 2 multiple x squared minus 16. And then I can say 2x minus 4, sorry, x plus 4. Okay? And this is not equal 2 multiple this and 2 multiple this. If you do 2 multiple both of them means 4, and that's wrong. I want to mention this mistake because I see this mistake many times. Okay, and I'm done. So yes, here. Okay, so how about this one? Okay, the same here. The same here. Oh, what do I see here? I see plus, but I see minus before. So I can do equal 300 minus 3b squared. Oh, perfect. This is looking good. This is looking what I want. The same what I want. Okay, so can I factor 3 here? Yes. Do I have common factoring? Yes. That's 3 here. So I do 100 minus b squared, which is 3 multiple 10 minus b multiple 10 plus b. Okay? Done. Good. So now we can move, so we can go here. So here I added many example of common factoring. So here is common factoring. Okay, so here is so you try common factoring. So oops, yes, so here you try to do common factoring, you try to do difference square. Okay, so many example, and I want you to work on them. Okay, so they are good example, and the more example you do, the comfortable you feel. So the more comfortable you feel, and so you can do examples here, you can find examples on Google, you can find example in Blackboard. So many practice there, and I really don't know what's going on in the file here, and it's driving me crazy. Okay, so here, so now I stop here, so I call this video 1, and then I do the rest, the next, just the rest in so other videos. Okay, so thank you for your time. Bye.